Get a free copy of Altium software using the link provided in this video description. Plus, when you sign up for an Altium Designer free trial, you will get Altium 365 and 25% off discount. Hi, and welcome back to our video series on designing the Arduino R4 Mini-Mac in Altium Designer. In our previous videos, we've laid the groundwork creating the schematic and ensuring everything is in order. For this video, we'll delve into effective strategies for placing components to optimize signal integrity, minimize noise, and enhance thermal performance. By the end of this video, you'll have the expertise to create a well-organized and high-performance PCB layout. So now let's get started. So this is what we left off in the previous videos. Building on our progress from the previous video, we discussed the engineering change order or ECO process. We're now ready for the component placement. Before we start moving the components, we need to set first the board size. Setting the board size before component placement is essential for the overall success of your PCB design. It provides a foundation framework within which you can efficiently arrange components, ensuring a well-organized and optimized layout. This early decision prevents issues like overcrowding or component misalignment, which can be challenging to rectify later in the process. Additionally, it helps you meet any project-specific constraints or size limitations, ensuring that your PCB fits perfectly within its intended form factor or enclosure. Ultimately, defining the board size upfront saves time, reduces the risk of errors, and streamlines the entire PCB design process, from component placement to final routing. To set your desired board size, press 1 on your keyboard to activate the board planning mode. Then click on Design, then click Edit Board Shape. Now you can see snap point on the edge of the board. You can simply click, drag, and hold this to your desired board shape. Now press number 2 on your keyboard to back into the view. Now since we have the board size of the Arduino, let's proceed by representing it in our PCB layout. We can achieve this by plotting the outline using lines within the PCB editor. Just click on Place, then click on Line. Now we can draw the outline of the PCB based on the datasheet of the Arduino. After the board outline has been set, select the outline created, then click now on Design, then click on Board Shape, then click Define Board Shape from selected objects. This step ensures that our PCB layout perfectly matches the dimensions and form factor of the Arduino, allowing for a precise integration of components and connectors. By aligning our design with the provided board size, we ensure that our PCB is not only fits perfectly but also functions optimally within the specified form factor. Now that we have a board shape, we can start now with the component placement. To move the components in Altium PCB, begin by selecting the desired component with a click. Once selected, you can simply click, hold, and drag the component to your preferred location on the PCB. While holding the mouse click, you can also press the spacebar on your keyboard to rotate the component. Altium Designer provides a range of tools for precise placement, including the use of arrow keys to fine adjustment and snap-to-grid functionality. You can also move multiple components simultaneously by holding down the Shift key while selecting them. This flexibility ensures that you can arrange components optimally for your PCB layout while maintaining the design precision. After you've successfully dragged and placed all the components on the PCB layout, it's a great practice to validate the physical placement. You can achieve this by activating the 3D view in Altium Designer. The 3D view provides a realistic representation on how your components will physically sit on the board. It's a valuable tool to check for any mechanical clashes, ensure components fit within an enclosure or form factor, and assess the overall aesthetics of your design. By utilizing the 3D view, you can confirm that your component placements align with the intended physical requirements. enhancing both functionality and the final appearance of your board. To activate the 3D view and PCB, just press 3 on your keyboard. Sometimes, the PCB requires customization based on client or customer preferences. To change the solder mask of your PCB, just go to View Configuration panel, make sure that you're in the 3D view, then click on the top solder mask, then choose the color of what the solder mask requires. Choose it for top solder mask and bottom solder mask. Altium Designer allows you to customize the solder mask color to meet these preferences. This is not only add a personalized touch to the PCB, but also aligns the design with the client's visual or branding requirements, making it a crucial aspect of PCB design customization. Next, we need to set the layer stack-up of the PCB. The layer stack-up of a PCB is a critical aspect of the design as it determines the arrangement and order of the different layers that makes up the board. Properly setting the layer stack-up is essential for ensuring the board's functionality. To set the layer stack-up in Altium Designer, just click on Design, then click Layer Stack Manager. It will open another tab, and you can add a layer by right-clicking on the top layer, then click Insert Layer below. This is where you can choose if the layer you want to add is a signal or a plane. In Altium Designer, you can define the layer stack-up by specifying the number of layers, their types, signal, power, or ground, and their thickness. You can also assign specific signal or function to each layer. After you're done setting up, close the Stack Up tab, then click Save. Now to check the assigned layer, go to View Configuration tab, click on the Layers and Colors, and now you can see that there's the added layer. Next, we need to add a via fan-out in the components. Adding a via fan-out is crucial for efficient signal routing in PCBs with components featuring a high pin count. It simplifies the routing process, reducing congestion on the top and bottom layer of the board. This is not only aids in completing the design but also enhances signal integrity by providing shorter and more direct pathways for trace. So, to add a via fan-out, first, place a track. To add a track, click on Route, then choose Interactive Routing. Select it to the pin of the pad, and left-click to end the command. Now to add the via, click on Place, then Via. Then press Tab on your keyboard to access the properties of the via. Now this is where we can change the diameter and the hole size of the via. Then snap it again to the end of the track. Then right-click to end the command. Via fan-outs also allow for better thermal management as they help distribute heat across internal layers, preventing localized hotspots. Overall, incorporating via fan-out is a fundamental practice for achieving a well-optimized and reliable PCB design. After you place all the via fan-out, you can see now that these vias act as a gateway for signal to move between different layers. If we go to the internal layers, we can route freely the pad at the top layer in the mid layer. Next stage of designing the Arduino R4 Minima is the routing stage. This is where you physically connect the components and create the pathway for electrical signals. It's a delicate balance of optimizing signal integrity, minimizing interference, and ensuring manufacturability. Just pay close attention to the factors like trace length, width, and the spacing, as they directly impact the signal quality and the impedance. To route the PCB, use the Route tool in the Altium Designer. Click on Route, then choose Interactive Routing. Begin by clicking on the starting point of the trace, typically a component pin or a pad. Drag the trace to its destination, adjusting the path as needed. The Altium will often assist in maintaining precise alignment. Click on the endpoint of the trace, then right-click again to end the command. Now repeat the same process in all the unrouted nets in your PCB design.
Just select the route tool, click on the starting point, and drag the trace to its endpoint. So this is the final conclusion of our board design. As we end this video series, after completing the layout, I trust you've gained valuable insights about the Arduino R4 Minima. I hope this video series has been a source of knowledge and inspiration to you. Stay tuned for more upcoming videos where we'll delve deeper into the fascinating world of electronics and innovation.